Okay, so we are live. Right. I'm coming live after like 2 days. I've been busy with like college. We had to submit our minor project report and all that. But I guess now I'm kind of free, so I'll probably get back to my consistency. And yes, today we'll be solving the problems from the last contest, the third problem. I was really close for that problem. Let's see. Let's see if I can solve that on my own. Right, I think it was a weekly contest or what? Let's start. Did we get a rating update? No, it's what is it? It is Tuesday, so we don't get it on Tuesday. Hmm. My rating is going to drop, that is for sure. Okay, this was the question. What was my submission? 416 test cases. I'll be writing the code from scratch today, by the way. Hmm. Okay. So the description is pretty simple and it looks like a very straightforward question, but it definitely isn't. You're allowed to replace at most one element in the array. Return the length of the longest non-decreasing subarray that can be obtained after performing at most one replacement. Hmm. Right. Okay. The last time I approached this question by calculating all the increasing subarrays, right? Increasing or non-decreasing. That means there can be repetitive elements. That's the same thing. We first need to calculate all the thing is the screen isn't blur, right? No, it is not. So calculate all the increasing subarrays and then we have to check if we can add them. Then we have to check if we can add them. By adding them, we mean that we replace one element so that they both become eligible to add. This was the approach I was following in contest, right? But the thing is, if we can't add them, we can always achieve length plus 1. The length of that increasing subarray plus 1 because we can replace one element. What I'm talking about, let me take an example. Bro. Okay. Let me take an example like 1, 2, 4, 7, 6. And probably let's say 8. Then we get 3. Then we get a 9. Then we get a 2. Then I don't even know. So in here we can have a, this is a increasing subarray. This is a increasing subarray. This is an increasing subarray. What we can do is we can replace this 3 with an 8. Right. Then we can add this with this to achieve a length of 1, 2, 3, 4, 5, 6, 7. 7. So the condition to add two increasing subarrays is that the start of the right subarray, no, the second element, so the condition is Let me write the condition. To add two different subarrays length, we have to check if the last LE of left sub array is or equal to smaller than or equal to the second element of right the subarray. This is our condition. This is our condition because let's say we had a 7 here. Okay, then we can't add these two. We can't add these two. Why? Because this, even if we make this as an 8, it's going to be 1 3 4 6 8 8 and 7. So that condition is correct. Let's start by initially first calculating all the answer would always be int prev equals to int min. For int LEF, I think we'll have to go with like this. I can't type, by the way. It's so cold in Delhi that my hands are like kind of numb. So the first step is to calculate length of all increasing subarrays. Okay, increasing or non-decreasing. Int length equal to 0. If arr I is greater than or equal to prev, then we can say len plus plus. Else else cout len okay, and len equals to 1 and prev equals to arr I. Okay, the last length we'll have to say it out ourselves. Turn -1. This should at least like give us all the lengths. So 1 2 3, we have a 3 and 2. Makes sense. We have a 5, right? We have a 5. Now the thing is, you have to see. I'm trying to do it in one pass. What is the... So we're getting the lengths. Now here comes the tricky part of how to decide if we want to add the left array length. Right. This length is basically int current length equal to 0, right, and left len okay, we don't need a cout. what we're gonna do is we calculate current length. Now, as soon as we hmm, breaking up a copy for your head. I'm breaking up a copy for your head. We'll get our length till here. Our C length here would be 1, 2, 3, 4, 5. As soon as we come here, our C length would become 1. But we'll have to check that do we have to add the left length? Hmm. 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 We'll have to. Hmm. 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 This is where I was stuck the last time. This is where I'm stuck this time. We have to check if the last element of left subarray is smaller than or equal to the second element of the right subarray. Even if it is, hmm, ठीक है, increasing चल रहा है, decreasing आया, else decreasing आया. So what we can do is our C length would become 1. Okay, our C length would become 1. That's obvious. Let's give it simpler names, but what the fuck am I writing? L length. Okay. Our C length would become 1. अगर कोई भी decreasing आया, now we'll have to check that check whether we need to add left length or not. For that we add a condition, right? इस पॉइंट पे हमें चेक करना पड़ेगा कि क्या 8 the number on its left is the number on its left should be less than or equal to number on its right. तो हम ऐड कर देंगे लेफ्ट लेंथ को. ओके, तो हम ऐड कर देंगे लेफ्ट लेंथ को. ओके, add L जैसे डिक्रीजिंग आया, we need to check whether we need to add left and or not. If first thing is, एक ये भी तो केस हो सकता है कि यहाँ पर ब्रेक हो रहा हो तो आप लेफ्ट को तो देख सकते हो, राइट में तो कुछ है ही नहीं ना. हाँ, तो दिस वाज एन एज केस. यहाँ पर ब्रेक हो रहा है तो यू सिंपली डू फॉल्स. वी कैन नॉट. Let me get check whether we need to add left length or not. If ठीक है ना, पहला चेक अगर लास्ट एलिमेंट है तो if I equals to error dot, I didn't take I equals to n minus 1, so we can say add length equals to false. If else if we can say error I minus 1 should be either less than or equal to error I plus 1. So add length equals to true, else add length equals to false. Okay, we did cln equal to 1, but r all equals to cln. Okay. There's also one another like approach we can do is that we don't need a boolean. All we need to do is, if it is not eligible to add, we do left length equals to 1. We can always add 1, right? We can always add 1 if there is a decreasing. We can always add a 1. Of course we can. But the thing is, have we not? Man, this shit is confusing. Bro. What I'm doing here is, this question is crazy. Let's see, what I'm doing here is, I go over this. At this point, look at it. I get 5 here, and I'll get 3728 here. Max between ln plus 1 comma answer. Okay. Basically what is doing, लेफ्ट में 1 ऐड तो हमेशा कर सकते हो, लेफ्ट में 1 ऐड तो हमेशा कर सकते हो. चेक वेदर वी नीड टू ऐड लेफ्ट लेंथ नॉट. ठीक है, वरना लेफ्ट लेंथ फॉल्स हो गई. इफ ऐड लेंथ है, अगर ऐड एन लेंथ है, अगर 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 ऐड कर सकते हैं तो अगर ऐड कर सकते हैं तो आंसर इक्वल टू मैक्स बिटवीन. See, that's the point. अगर हम ऐड लेफ्ट लेन कर सकते तो आंसर वुड बी मैक्स between, answer would be the max between c length plus l length का आंसर। अगर हम ऐड नहीं कर सकते, अगर हम ऐड नहीं कर सकते I feel like I could solve it very neatly. Like right now, I'm making things extremely confusing. Calculate length of all increasing sub-arrays increasing चल रहा है. You know what? Let's do this. We don't need a add a length. If we cannot, wait. The answer equal to max left length plus 1 भी तो आप देख सकते हो, ठीक है? अगर ऐड कर सकते हो तो बेस्ट है, लेकिन लेफ्ट लेंथ कोई भी ब्रेक आया तो यू कैन ऑलवेज डू लेफ्ट लेंथ प्लस 1. हमने सी लेंथ 1 बना दिया, ठीक है ना? नाउ व्हाट वी डू इज, अगर तो आप कह सकते हो एल लेंथ इक्वल्स टू 1. लेट मी फ्रेम इट एज इन कि हम हमेशा राइट सब एरे के लिए चेक करें हम लेफ्ट को ऐड कर सकते हैं कि नहीं. राइट सब एरे के लिए हम चेक करें लेफ्ट को ऐड कर सकते हैं कि नहीं. दैट्स गोइंग टू कवर ऑल केसेस, राइट? सेकंड के लिए फर्स्ट को, थर्ड के लिए सेकंड को. अगर ऐड नहीं कर सकते तो ये लेफ्ट लेंथ ना आप सी लेंथ तभी बनाओगे अब क्या कर रहे हो बेसिकली. अगर हम ऐड कर सकते हैं तो आप कर दो लेफ्ट लेन इक्वल्स टू सी लेन, वरना यू जस्ट डू equal to 1, ठीक है ना? we got rid of the boolean. The answer would always be c length plus l length or c length. I feel like, yeah, this might be it. Let's at least try running it. Hey, try solving two arrays. Hi bro, what's up? Try solving two arrays which will tell the maximum increasing length till this index and maximum decreasing length till index right. Okay, I'll have to think about that. Which question, bro? It is the two cases ran. It is Leetcode 3738. It was the third question in the last contest. Okay, this ran, but I'll need to run my own test cases. Okay, let's say we had a 1, 2, 3, 4, 5, and we had a 3. After that, let's say we had a 4, 5, 6, 7, 8. Then we had a 2, then we had a 9, then we had a 10. I don't even know what I'm doing at this point. Yeah, so we're getting a wrong answer for this. Let's debug. Cout break at index I l length becomes l length Okay, so we get break at two indexes. Index 4, 1, 2, 3, 4, 5. This is, yeah, we got a break at this index and we cannot add. I'm obviously checking for the left one. Okay. We cannot add, so left length becomes 1. Absolutely. From this point, the left length becomes 1. 3, 4, 5, 6, 7, 8. And then we had a break at index 10. This is 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Left length becomes 6. So left length is 1, 2, 3, 4, 5, 6. Yeah, left length becomes 6, 7, 8, 9. Output is 9. What? How is expected 10 here? 1, 2, 3, 4, 5, 6, 7, 8, 9. How is the expected? What? What am I missing? How is the expected 10 here? What the hell? How is the expected 10 here? 1, 2, 3, 5. Then we get a break. And we clearly cannot add left length anymore. So left length becomes 1. Then we go 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bro, expected is, how is expected 10? What? How? How even is expected 10 here? Does anybody have any idea? Like, how is the expected 10 here? What? What is the question? You're allowed to replay at most one element in the array with any other integer value of your choice. Return the length of the longest, non-decreasing. If array I is greater than equal to previous. How is, bro? 1, 2, 3, 5. It is in. Let's plot this. Right. It's saying 10, but 1, 2, 3, 4, 5, 6, 7, 8, 9. What the? How is it 10? Longest? What is happening? Bro. How is it 10 here? I can't wrap my head around this bullshit, bro. We want the at most one element in the array with any other integer value of your choice. Return the length of the longest non-decreasing subarray. Right, we can change this and bring it here. Okay, so that it becomes this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I stupid? Or is the expected is 10? I'm getting 9. Does anybody have a clue? Bro, I need to understand. Let me get the answer explanation from Leetcode. From a ChatGPT, I mean. Not ChatGPT. Let's talk to Cloud. I'm not asking the answer logic. I just want to know how is the answer 10. just the answer of test case. Maybe I'm missing something very obvious and I might sound super dumb. For 10, wait, I'm 1, 2, 3, 5. 1, 2, 3, 3, 3, 4, 5, 6, 7, 8. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Bro, this question is crazy. Expected output 10. Wow. So basically what we're doing here is 1, 2, 3, 5, and then we get again a 3. These are the same level. Oh, so it's bringing it here. It's bringing it here. Hmm. So there are two conditions that I need to check. Wow, I didn't think of this. That this is the break element. If the break element is equal to this, no. What's up, bro? मैं हूँ Lectors. What's up, Naman, bro? Bro, 1, 2, 3, 5, which you can change. So total 10. I didn't think about that. That is AQI ठीक ठाक. Not at all, bro. Not at all. That means I was thinking it all wrong. We brought it down. This is a crazy question. At this point, right, so we have these arrays which are increasing. Okay. The point is, if you can add them, my condition could successfully like identify that we can add them, but I couldn't realize that we could also add these. We could also add these. We'll have to check at both breaking points. At this point, I consider this and this, right? Now at this point, I'll have to consider this and this. Okay, so it's just an extension of my logic. Mason PUBG. Hello Mason, bro. Are you building anything side by side? Not really, I'll be honest, not really. So we just have to do a check. We can, right, you know what? We can turn this into a function. Tool eligible to add. That's going to take in your vector int arr, and it's going to take an index int I. So the point is, yeah, the same conditions. The conditions are same. Okay, format this. Alt Shift F. Okay, it formatted the entire file, but okay. If then we return length equals to return false, return true, return true, else we simply return false. Okay, now what we're doing here is, my code looks so ugly after formatting. Bool add left. Bool add left equals to false. Right, let's wait, what let's just comment this out. Bool add left equals to let's keep it like that. Bool check at I equals to, or if I equals to 0, return false. Yeah, this is a new condition we need to add. Because then we cannot check its previous, right? Check at I equals to eligible to add your ARR with current index, and you do check at I. What is my naming convention at this point? I minus 1. Eligible to add I minus 1. Okay. Add left would be the, or would be check at I or check at I minus 1, right? Now we decide using this. If add left, then we can say L length equal to C length, else L length equals to 1. This should be placement हुआ क्या? I do have an offer though. I do have one offer. I tried solving this using sliding window, couldn't solve it completely. Later used prefix and suffix arrays to store the length of non-decreasing subarrays ending at I minus 1 and starting at I plus 1. Okay, I'll think about that. I'll probably have to go your approach because if mine isn't working. What? Okay, so it is working. Let's write a few of our own. Let's say we have 2, 2, 2, 2, 2, 2, 2 and 1. Okay, that would work. That would work, obviously. Let's say we wrote, what do we, let's try some random test cases. I'm 99% sure this is still isn't the correct solution. Wait, I need to bring myself here. It is working. Yeah, let's use test cases from my wrong submissions. Use this, right, and then use this. Okay. This might just be correct then. Let's submit it, bro. Memory limit? Memory limit? Are you serious? Where the fuck am I doing memory? Where am I even playing with memory? Okay, probably because. Hmm. Hmm. Come on, bro. This was an unnecessary error. Accepted. Damn. So it did run. It was correct, but this is like a very smart question, bro. I would have never been able to solve this live in contest. It has 18% acceptance rate. Makes sense. Very smart question, bro. Fix the code. So the only thing I was doing wrong is whenever I found a break in these increasing subarrays, I was only checking from this index. I should also check from this index. Okay, now that I look at it, it isn't fairly like difficult. No, I'm joking. This was a difficult question. Hmm. Explain your approach once. Okay. So basically, my approach is first of all, of course. Wait, let me raise this. Why is it lagging? Okay, let's clean up my diagram. Bro, what the hell? Okay, so my approach is, of course, we'll have to first find all the increasing subarrays, right? Now, the only question in picture was, can we add two increasing subarrays or not, right? That was the only question, because if we can add, then the answer would be the length of these two both. If we cannot, then of course we can't. To check if we can add or not, I'm simply using this logic. To check if we can add or not, we check from two indexes. I initially only checked from this index. That was wrong, right? We need to check from two indexes, the end of left subarray and the start of right subarray. How do we check? We check if we can add, if we can we check if we can add basically by comparing the left and right elements. Since we are checking from this element, we compare the left and right. If the left should be your less than or equal to right, then we can add, right? If we cannot do that from here, we'll also have to check from here. From here, see, left is less than or equal to right. It is, they both are equal, so we can add. How do we add? We bring this down to this level, and then this becomes a non-decreasing subarray. Okay, so we do can add. And basically, if we can add, we remember the left length, the left subarray. If we do not, then we make the left length as 1. We make left length as 1 because we can always replace one element get an extra 1 in the answer, right? If let's say this was mm, let's say this was here, right? And then there was this. Basically, you get the idea. We can always add 1 to any break. This was my approach. I was The mistake I made was I was only checking from this index, but I also need to check from this index. Bro, CF Div 2 was so hard. I mean, Division 2 is known to be really hard. I have seen a few questions. They always like, I think the second question itself goes up to the rating of what, 1200? I don't know. This was a very smart question. Okay. Coming to yesterday's POTD, I saw that problem. Looked really interesting. What is today's POTD? You're given an array of binary strings and two integer m and n. Return the size of largest subset of strings. Okay, we need a subset of it such that there are most m zeros if all elements of x what is this question saying? Array of binary strings in the subset 5 zeros and 3 ones is is this a DP question? Pick no pick question? Is this a DP pick no pick question? It has 50% acceptance rate. It might just be that. Like for every element, if it is valid, we do pick or no pick, and then should we do this or yesterday's question? You are given an array of binary strings and two integers m and n. Yeah, this might just be a DP question. If you think properly, it's just a bounded knapsack problem. Right, knapsack is just pick or no pick, right? That's what you're saying, right? Knapsack. Right, that's 0 or 1, pick or no pick. It's a pick or no pick. I'm not really that good in DP, but let's try. Let's make the approach first. In the last contest, I tried doing a DP question without making an approach, and I ended up giving up. So the thing is, we have these elements. What the hell? So for this element, we can either pick it or not pick it. If we pick it, we do return. Why do I feel like this is fairly straightforward? The stakes in are right. It's going to take a PTR, and I think that's it. That's it. So int n equals if PTR equals to n, return 0. We also need to have a valid, right? Bool valid. This is going to take in a string and s. Basically what this function is, this checks if we can pick or not pick, and it's going to take int m comma int n. Because what if there is a string that exceeds m and n on its own, right? No, but at the same time, oh yeah, the values of m and n will, the values of m and n will 5 zeros and 3 ones. So Oh, okay. Hmm. All right. So the value of m and n will be updated for every pick and not pick. Int one limit, int zero limit. Hmm. What would be the dimensions of the DP array? Exactly. That's what I'm thinking. This is becoming 3. See, that's the point. This is what always stumps me, bro. I might write the code, but I'll always get stuck at memoizing it. Like at this point, it would require me a 3D array. You know what? Let me just first write the code. Who knows? This, let's write a function. I am absolutely terrible in DP. This returns a number of ones and zeros. Going to return a pair of intent count. This is going to take your string in s. That is it. That is it. Int o count equal to 0. Z count equals to 0 for car c of s if c equals to 0. It's a binary string, of course, right? If c equals to 0, z count plus plus else 1 count plus plus. We're going to return 0 count and 1 count. M zeros and N ones, right? Pair of int counts equal to count your error ptr. So let's just do string current equals to error ptr. Int one count would be your counts dot second. Int 0 count would be your counts dot first. Bool valid means if we can pick it or not. Bool valid is 0 count is less than equal to 0 limit, and then 1 count is less than equal to 1 limit. If it's invalid, then we simply skip. Then what we do is error return solver error ptr plus 1 limit remains the same, and 0 limit remains the same. If it is valid, else I hope I'm going 3D DP 0, 3D DP, zeros, ones, and index is 3D. Okay, so there's nothing wrong with making a 3D DP array, right? I thought that's a problem. Okay, okay, that makes sense. Why no need of a function? No, that function is basically to make my code a bit neat. I'm just returning the count of zeros and ones, right? And if it is valid, then int skip would be solver of error ptr. One limit remains the same, 0 limit remains the same. See, the point is we should have zero limit first. Zero limit, one limit. Zero limit, one limit. Okay. If equal to zero limit and one limit, right? Bro, this is your skip. Int pick equals to solver error ptr. Zero limit becomes zero limit minus zero count, and one limit minus one count. As simple as that. Return maximum between pick comma skip. Solver, it's going to take strs and it's going to take 0. It's going to take m and n, right? Let's hope this works. I still need to memorize, I know that. Current. Hmm. What's the thing? Zero limit, one limit, zero limit, one limit, zero limit, one limit. Okay. Stack Overflow. Why? I'm checking if it is out of bound. Why is there a Stack Overflow? Okay, pick, stupid me, skip and all. They should always have a PTR plus one. Wow. What am I doing wrong? Oh, pick is 1 plus. So this looks okay. See, the thing about me is I have always hated memoizing with arrays. I've always like tried to use maps because I always forget the syntax of how to declare a 2D array or 3D array. A simple one can be declared like vector int arr is going to be of size comma elements, right? This is vector int name. This is how you declare a 1D. For 2D, this is 1D. For 2D, you go vector int name, outer name, outer name. We don't need a name of inner one. You do size, and the element would be vector int. Vector int. The element would itself be vector int, and it will have its inner size. We have a outer size vector int inner size, and its element would be element, right? Now for 3D, we'll go vector int name outer size is going to be a vector of vector. See, that's the point. It becomes confusing at this point. Middle size, yeah, it's going to be a vector of int middle size, and inside the middle size we'll have a vector of int who's going to have inner size with element. I hope this is how we declare it, right? Yo, what's up, Cruz? What's up? My lead code ID. Have you worked with okay, my let me give my lead code ID. Have you worked with geometry nodes in Blender? I did. I did, but long time back. I did. In fact, you know what? If I were to show you one of my works in Blender, let me just hide the screen for a second because I'll have to go through some old chats. Okay, Discord is running. Let me wait until Discord runs. Just declare it globally. In which college are you? I'm from a college in Delhi. It's IPU college. Vector int. Just declare it globally and resize in main function that no need to pass. Okay. I'll have to see about that. Let's first see if this declaration is correct. This is vector int hash. The outer size would be what? We don't care about sizes, right? At this point, we don't care about sizes. Yeah, we don't care about sizes. All we care about is element is -1. Is this correct declaration? You come live at this time? I mean, I'm not really sure. See, I might come live in the day. I came live late today because I had to go to college. I'm in my 4th year. Okay, I was showing you guys that that Blender thing. Let me find it. Yeah, here it is. Okay, I hope it's visible, right? Yep, it is. So this was a scene which I created back in 2020, entirely using Blender. I mean, it's a very famous Blender guru's donut tutorial. ग्लोबल डिक्लेयर करके असाइन कर दे फंक्शन में. Okay, let me learn how to do that. I do not know how to do that. I've always used maps. Oh, of course, yeah. Is how to declare declare globally, then resize in later. Okay. So resizing obviously looks much better. Let's declare it globally. Vector of hash. It's going to be a vector, and it's going to be a vector. Who was that guy, Pradeep, bro? Do you know how to find the shortest path from node A to node B? No, bro. It's been 5 years since I last used Blender. I have absolutely no clue. And what we do is hash dot resize. First of all, int n equals to your n equals to strs dot size dot length. Okay, str dot length. In our hash, we'll go with an order of ptr m comma n, right? Ptr m comma n. Right. Hash dot resize. Hash is a vector. Hash will have vector of int. Make hash of the size. Ptr can go from 0 to n. Let's give it n plus 1. That's how we do it, right? X and vector of int, right? Now inside here, it would be m, and it's going to have a vector of int. It's going to be n, and the elements would be -1, right? What am I missing? Okay, that's just my closing error. Let's add the hash functionality. We don't even need to call it, right? If hash ptr 0 limit 1 limit not equal to -1, return equals to would this work? hash assign बाकी सेम. Bro, your keyboard सही है. Bracket copy नहीं है इसलिए गलत बोल रहा है. Yeah, I got it. strs dot length redefinition of n. And what is n in the question? Oh, what do I name this? Length. Oh, bro, it's an array. What am I doing? Vector of strings. Like the pointer can be go from. Okay, I get it. What the fuck am I doing? It's because I need to do m plus 1 and n plus 1. Let's see. Pretty cool, right? 5%? 5%? Why? Why is this so inefficient? What is this guy done? Okay, he did tabulation. See, that is something I can never do. Vector of int dp. Let's not even try looking at this. Cause of recursion stack space. Okay, Recursion stack space. Makes sense. Nah, 3K. Look at my summation to this most recently solved. Let's look at your bro. What? 558 questions. Damn. 64 hard question. That's crazy. See, you've written such neat code, and look at my code. It's it's taking an index mn and it's taking a 3D array. If it is end, it is returning 0. Else, it's returning the hash. Okay, that's what you're doing. Int not take equal to help here. Int take equal to 0. Take equal to 1 plus. Yeah, you've written. You made this look so easy, bro. If I okay, so the difference is I created this function, you counted it in itself. Damn, bro. How many contests have you given? 18? Wow. Nice. Now the point is, do we solve this too or keep this for tomorrow? Because I'll be honest, I've read this question yesterday and I'm really like inclined to try this. But I don't know, it's already 6. I need to go to the gym. I guess I'll end the stream right now. Okay, yeah. So this is it for today. I'll end the stream now. Let's do it. Kirtan, bro, it's already been like what 1 hour 13 minutes. I actually have to like do some file work for my college. I'll do it tomorrow though. Yeah, we'll do it tomorrow. Live on stream. Alright, tomorrow, yeah. Thank you for staying throughout the stream. I realized that you've been here since like the start. Yeah, since the first question which I was solving. Okay. Okay, so that's it for today. Thank you to who all those joined. Bye bye.